The goal of this presentation is to show you how using empty device principles to create a positioning device with accuracy higher by order of magnitude than devices mentioned in previous presentation of empty device series. Precision is higher. That is why we can speak about primary standard for this type of measuring tools. It is logical to assume that if we reduced the thickness of measuring tip by the factor of 10, it was, as you remember, 1 mm, and now it would be 0.1 mm. The accuracy of this tool also to be reduced by the order of magnitude. Only the questions: how reliable we can optically recognize so-called calibration position of so small details of this device. We will start with the measurement of the length of empty device, but before it, I'll show you shortly how to make this device using medical and improvised materials. I'll take a tool which we put on the ionization chamber and which consists of thin washer, vertical rod and plumb wire. The 2 mm in diameter needle I use as a rod of empty device. I drilled some holes in needle and washer to help me connect washer with rod by soldering. As a result, the rod and washer should be lined up. Suitable for making measuring tips wire with diameter approximately 0.1 mm I found in cable braiding. Colored to black piece of wire I glue to the tip of the needle. Now we have got measuring tool with 0.1 mm tip and its top, and our next step to measure the length of this device. As you see, caliper fixed vertically in the device and empty device is freely hanging on the lower jaw of the caliper. Of course, you should have special pusher for slightly moving down upper caliper jaw. You see the reflection of the measuring tip in upper jaw of the caliper, and you can visually recognize calibration position using empty method described earlier, when we see imaginary square between tip and its reflection. Now about the holder of mold probe. It has new arc-type design to minimize amount of non-aqueous material around the radiation source, and as you see, source catheter is curved in order to make an effect of pressing down the end part of the cable with the source to be sure that radiation source now in direct contact with the lower wall of the catheter. The holder of mold probe is fixed on the phantom one direction precise moving mechanism. Pharma ionization chamber is fixed to its standard place as well. And now we can see how all this system looks like. The distance between radiation source and pharma ionization chamber we can precisely adjust. And so, in this version of measuring procedure we are doing following step. First, we place position in mirror, we put empty device and adjust catheter to chamber distance, we remove mirror, we remove empty device, finally we send radiation source to the calibration position. Special care was taken about levelness of position in mirror. For example, we used laser beam for this type of adjustment. Laser beam incoming into water phantom through scaling marking on one side of the phantom after reflection from the upper side of position in mirror should symmetrically outcome from the another side of phantom through equivalent scaling marking values. For the same purpose, we rotated the empty device on ionization chamber. The result of measurement should be the same for both positioning. To distinguish thin tip of measuring device, we use universal with 8 times magnification telescope for iPad together with lens of +8 dioptries in order to reduce focus distance for all this optical system. One of the parameters of pharma ionization chamber is calibration factor for absorption dose to water. Energy correction factor for pharma ionization chamber we found by interpolation its energy correction factor from calibration certificate. So we have good result for dose rate measurement 0.4121 gray per minute. Then we should do 2 geometrical correction for distances. Firstly, we should take into account the distance between tip and surface of mirror. It is plus 0.05 mm. And secondly, when we measure empty device length by caliper, the result little bit longer due to certain widths of lower jaw of caliper. This correction will be minus 0.025 mm. The correction for longitudinal extension of pharma chamber we took 0.6 mm as in previous presentation. Summation of all these constant and corrections gives us final difference between radiation source and center of ionization chamber 42.85 mm. The planning system Brachyvision version 10 gives us for iridium HDR source the dose rate at distance 42.85 mm in water phantom 0.4177 gray per minute. It is higher than our measurement by factor 1.3%. But if we compare source calibration performed by well ionization chamber when activity of source was measured 1% lower than in calibration certificate of the manufacturer, we will get unbelievable difference for TPS2 measurements, a result 0.3%. Finally, we have came to conclusion that our primary standard gave us good result and it can be recommended for quality control procedures. Thank you for attention.